Cast your mind back to 1977. It was a time of great imagination. We were sending messages in a bottle, not into the ocean, but into the cosmos itself. On the 5th of September, a rocket roared to life in Florida, carrying a precious cargo. This was Voyager 1. It was more than just a machine of circuits and metal. It was a representative of humanity, an emissary to the stars. Its mission was ambitious. It would fly past the gas giants, Jupiter and Saturn, using their immense gravity to slingshot itself ever deeper into the void. It carried with it a golden record, a time capsule of our world filled with sounds and images, a greeting card to any civilization that might one day find it. Voyager 1 performed its initial mission with breathtaking success. It gave us our first truly intimate portraits of Jupiter's swirling storms and Saturn's magnificent rings. It revealed volcanic activity on Jupiter's moon, Io, and hinted at a subsurface ocean on Europa. These were not just pictures, they were revelations that reshaped our understanding of the solar system. The spacecraft was a pioneer, charting a course through territory we had only ever seen through the lenses of telescopes on Earth. Each piece of data it sent back was a new page in our collective cosmic storybook, a story written across billions of miles of empty space. After its planetary encounters, Voyager 1's journey was far from over. It just kept going, speeding away from the sun at over 38,000 miles per hour. It was destined for a place no human-made object had ever been, the vast, unknown expanse between the stars. For decades, it traveled silently, faithfully reporting on its environment. Then, in 2012, a historic moment arrived. Voyager 1 crossed a boundary called the heliopause. It had officially left the protective bubble of solar wind created by our sun and entered interstellar space. It was now sailing on the stellar seas, a tiny man-made object in the realm of the stars. Think about that. An object built by human hands, now swimming in the cosmic medium that fills the gaps between solar systems. It is the most distant thing we have ever sent anywhere. It is our silent scout, our first true interstellar explorer. It continues to send back invaluable information about this mysterious region, data on cosmic rays and magnetic fields that are completely unfiltered by our sun's influence. Voyager 1 is not just a relic of the past, it is an active scientific instrument on the grandest of all frontiers, a testament to our innate desire to explore what lies beyond the horizon. To keep sending us its precious scientific postcards, Voyager 1 must do one thing perfectly. It must keep its main antenna pointed directly at Earth. Imagine trying to talk to a friend across a vast city using only a tiny, focused beam of light. If your aim is off by even a fraction, the message is lost. For Voyager 1, the challenge is infinitely greater. The spacecraft maintains its aim using tiny thrusters that fire in short bursts, a process called a roll maneuver. These thrusters are the key to its stability, the steady hand that ensures its whisper from 15 billion miles away reaches our planetary doorstep and doesn't just fade into the darkness. Recently, the mission faced a grave danger. The backup thrusters, which had been dutifully operating since 2004, were beginning to fail. They were becoming clogged with residue after years of faithful service, their performance degrading with each passing month. If these thrusters failed completely, Voyager 1 would slowly begin to tumble. Its antenna would drift away from its earthly target, and its voice would be lost to us forever. The decades-long mission, our only direct link to interstellar space, would fall silent. The thought was unbearable for the scientists and engineers who had dedicated their lives to this incredible journey of discovery. This is where the story takes a turn towards true ingenuity. The engineering team at NASA's Jet Propulsion Laboratory knew they had to act. They looked back into the spacecraft's history, searching for a solution. They found one, but it was a long shot. The primary roll thrusters, the ones the spacecraft was launched with, had mysteriously failed back in 2004. They had been dormant for over 2 decades, cold and unused. The team's hypothesis was that a random circuit disturbance, perhaps a stray cosmic ray, had flipped a power switch, cutting off heat to the thrusters and rendering them inoperable. The idea was simple, yet terrifyingly risky. Could they send a command to flip that switch back on? It was an audacious plan. The spacecraft's systems were old, designed in the 1970s. Sending a jolt of power to a dormant 20-year-old system could have unpredictable consequences. At worst, it could cause a short circuit or even an explosion, damaging the spacecraft beyond any hope of repair. the team had to weigh the risk of certain failure against the possibility of a miraculous recovery. They chose to take the chance, to place their faith in their engineering and their understanding of this distant machine. The team at JPL, led by people like Suzanne Dodd and Kareem Badaruddin, meticulously crafted the command sequence. It was a digital message of hope, a complex set of instructions designed to carefully awaken the sleeping giants, the primary roll thrusters. They had to be certain. A single miscalculation could spell disaster for our most distant explorer. Once the command was finalized, they sent it on its way from the Deep Space Network's antenna in Australia. Then, the waiting began. It is a wait unlike any other in human experience. Light itself, the fastest thing in the universe, takes more than 22 hours to travel from Earth to Voyager 1. The signal traveled across the vastness of our solar system, past the orbits of all the planets, and out into the interstellar medium. It was a focused whisper of energy, carrying the hopes of an entire team. Once it arrived, the spacecraft's computers would execute the command. Then, Voyager 1 would send back a telemetry signal, a report on its status. That signal would then begin its own 22-hour journey back to us. In total, the team had to wait nearly 2 full days for an answer. For 44 agonizing hours, they could do nothing but hope that their daring gamble had paid off and not ended the mission prematurely. This entire high-stakes operation was also a race against the clock. The only radio antenna on Earth capable of sending such powerful commands to Voyager 1 is Deep Space Station 43 in Australia. This crucial piece of our global communication network was scheduled for a major upgrade, which would take it offline from May 2025 until early 2026. The engineers had to complete the repair before this communications blackout began. If they failed, and the backup thrusters gave out during the downtime, there would be no way to re-establish contact. Voyager 1 would be lost in the silent dark for good. Finally, the signal arrived. The data streamed into the control room at JPL. The team held its breath as they decoded the transmission. The news was extraordinary. The command had worked. The primary roll thrusters, silent for more than 2 decades, had successfully fired. The heaters were on, the system was stable, and Voyager 1 was once again able to precisely control its orientation. A wave of relief and celebration washed over the team. They had reached across an unimaginable gulf of space and time to perform remote surgery on a 48-year-old spacecraft. It was a stunning achievement of human ingenuity. This incredible success means that Voyager 1's journey can continue. Its voice, which was on the verge of being silenced, can now carry on speaking to us from beyond our solar system. The spacecraft can now keep its antenna locked onto Earth, ensuring that the precious stream of data from interstellar space continues to flow. This data is unique. It tells us about the environment that future, more advanced probes will have to travel through if we are ever to reach another star. Voyager 1 is the trailblazer, the scout reporting back from the frontier and telling us what the cosmic weather is like out there. The mission's longevity is a constant battle against dwindling power. The spacecraft's radioisotope power source naturally decays, providing about 4 fewer watts of power each year. To keep the essential systems running, engineers have been making difficult decisions, systematically shutting down less critical instruments. In early 2025, for instance, the cosmic ray subsystem was powered down to conserve energy. This thruster repair was so vital because it ensures that the remaining power-sipping instruments can continue their historic work, potentially extending the mission's life into the 2030s. Every extra day of data is a gift to science. What does this all mean for us, here on Earth? It means that our curiosity has no limits. It shows that our desire to know, to understand our place in the universe, is a powerful driving force. The story of Voyager 1 is a profoundly human one. It is a story of bold exploration, of facing seemingly insurmountable challenges, and of finding clever solutions through collaboration and persistence. It reminds us that even when something is 15 billion miles away, it is not beyond our reach if we are determined enough. It proves that we can touch the stars, not with our hands but with our minds. This comeback is more than just a technical fix. It is a symbol of our species' relentless spirit of exploration. Voyager 1 is an extension of our senses, our eyes and ears, in a place we cannot yet go ourselves. It carries the story of our planet on its golden record, and writes a new story with every bit of data it sends home. As it sails onward into the cosmic ocean, it represents the very best of what we can be, curious, hopeful, and endlessly inventive. Its journey continues, and as long as we can hear its whisper, our own journey of cosmic discovery continues with it.